Well, good afternoon, good morning, or good evening, depending upon where you are in the world. And welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a polling question kicking off today's webinar, which I'm really excited about, so hopefully we can get everybody engaged. And at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is DRP and reliability, or validate your disaster recovery strategy, ensuring your plan works. Our speaker today is Jason Yee, who is a director of advocacy at Gremlin. Jason, thank you so much for joining me today. I really appreciate it. Before we get kicked off with your presentation, I do want to go ahead and push out that polling question I just mentioned. All right, guys, the polling question should be up on your screen. The question is, how much confidence do you have in your existing disaster recovery plan? The responses are very confident, fairly confident, not confident, I don't have a DRP, and what is DRP? You can go ahead and make your selection, and while we are waiting for everybody to do that, just a quick reminder that at any time during the presentation, if you have a question for Jason, you don't have to wait for the question and answer period to submit your question. Just use the GoToWebinar control panel. You can get your question in at any time, and then, as I said before, we will try to get to as many as we can during the Q&A after his presentation. All right, I'm going to go ahead and close this polling question down in about, excuse me, 10 seconds. So go ahead and get our final stragglers in, and then I'll close it down now in 5, 4, 3, 2, 1. Okay, let's take a look at those results. Jason, it looks like the majority of people have, they're fairly confident in their existing disaster recovery plan. That's kind of interesting. Followed closely, well, not really closely, but about half of those are very confident in their DRP plans. That's easy for me to say, their disaster recovery plan. So is this something that, does this jive with what you're seeing in the market, what you're hearing from your customers?
Yeah, I am actually rather surprised that most people are fairly confident. I'm curious, and we can chat about this more in the Q&A. I suspect that might be a general feeling, but there might be very specific things that you're feeling not so confident in.
Okay.
So with that, yeah, we can kick off and start getting into this. But
all right,
you know,
go
I did
right
have
on
that
in.
question. Thanks. I did have that question, right? How much confidence do you have in your DRP? And I think of all of us as we're thinking of disasters and what our DRP covers, there's always at least that little bit of doubt, right? Even for those of you who said you're completely confident in it, right? If you were to think about if an incident were to happen right now, right? You get an alert that calls you away from this webinar, and you're thinking about your plans, how comfortable do those plans make you feel in tackling whatever problem comes up? And so as you think about that, one of the things for me is that I think DRP is flawed, usually flawed. And it's flawed for 2 reasons. The first is DRP is inherently reactive and not proactive. And this is just by design, right? It assumes that there's a disaster, and so you're planning a response for this. And now some of you may quibble over words with me. I will cover that in just a bit. But the other reason that I think that DRP is flawed is that the severity of a disaster and how you respond to it is greatly impacted by your response during the incident, right? The severity of a disaster, and thinking about disaster plans, we always think about, what if I lose my database? Or what if, all of my data is gone? What if my data center falls over? All of those things, inherently, there's this presumption that it comes out of the blue with no warning. It's some act of God that a black hole just appears and swallows up a data center. But we know that that's not really true. We know that disasters come about because of how we respond to the incident before it's a disaster. So Charlene gave me a nice intro. For those who joined late or didn't get it or want a little bit more about me, I'm Jason. I'm the Director of Advocacy at a company called Gremlin. Previously, I worked for companies like Datadog, O'Reilly Media. I was an engineer at MongoDB. So I've worked at a lot of great places that have dealt with how you plan and how you build systems at scale, specifically for reliability. In my spare time, just little personal notes. I play way too much Pokemon Go. I drink way too much whiskey. And my pandemic hobby has been making chocolate from scratch. So I'm now a craft chocolate maker. That's probably my next career, hopefully after tech. If at any time, though, you have questions about any of these random topics, or hopefully questions about reliability, chaos engineering, and other things that we're going to discuss, again, we have that Q&A. So feel free to post your questions there. But I know oftentimes when I watch webinars and conference talks and things like that, it often starts mulling over in my mind. And it's the next morning while I'm taking a shower or going for a walk that I think of that question that's been bugging me, or that I finally wrap my head around. If that happens to you, feel free to reach out to me. I'm available on Twitter. My DMs are always open. So I'm getbisect on Twitter. And my email address is jyi@gremlin.com. Again, feel free to contact me at any time. Just to tell you a little more about Gremlin, because that's who I work for, Gremlin is a reliability platform. We build software that helps you do chaos engineering in a safe and easy way that allows you to test a lot of the stuff that you want to test to build up your reliability, including your disaster recovery plans. If you'd like more information, hit up gremlin.com. If you are missing out on things like getting stickers from going to meetups and conferences, the link right there, gremlin.com/talk/devops-drp. That's a place you can go and get some free stickers. We'll ship those anywhere in the world. There's some really cool stickers that we've designed. But that's enough of the pitch of who I work for. So let's get back to DRP, right? I had said that DRP, I think, is inherently reactive. And I know some of you are thinking, well, I wrote a DRP. I'm creating one right now, or I've worked on it in the past, and obviously the disaster hasn't come. So isn't that being proactive, right? I'm creating a plan before something bad happens. That clearly must be proactivity. And to that I say, no, or at least not really, right? You're still planning a reaction. In reality, we don't have this binary of something is operational and that's fine and everything's perfect versus disaster. When we think of disasters, they are gradients, right? They are a spectrum that runs all the way from minor annoyances, things like suboptimal performance, things that we normally overlook, or maybe we just put them in the backlog because we think they're too expensive to fix for the benefits that we would receive. And there's a range of incidents from those minor annoyances, those annoyances and minor incidents, to medium incidents, to severe incidents, to what we normally think of as those catastrophic disasters, right? And so there's this entire range. And so when I say that being proactive isn't just moving your planning or starting to plan before something bad happens, what I really mean is that proactivity is addressing things across the entire spectrum, right? We're broadening the idea of planning and reliability and what we need to do, rather than just disasters, to all incidents, right? So creating plans that include processes and culture and addressed incidents when they're minor, and that values practicing reliability in those small moments so that we're prepared for the big ones. Because if we're only planning for the big ones, well, as You probably know, for those of you who have done DRP, you may practice it occasionally, but generally it's not top of mind. It's not something that people take seriously until you're talking about it. So what I'm proposing here is, as you start to think about DRP, really you want to start thinking about building a culture of reliability. And that rather than a DRP as we traditionally think of it, a disaster recovery plan that has a bunch of things laid out, rather than a specific set of rules or a singular process for disaster recovery, we need to start thinking about how we can incorporate this and make it a part of everything that we do. Everything that our development teams are doing, or even before then, everything that our architectural design teams are doing, and have that permeate all of the code that's written, all of the platforms that we build, and the way that we deploy it, and the way that we run our systems. It's got to be in everything that we do. So how do we do this? Well, as mentioned, I used to work at O'Reilly. They've published some great books in conjunction with Google, because Google's this company, right? I mean, we all know Google from search and the tools that they make, like, Office and Chrome and things like that. But they're largely known for having written a lot about reliability because they run massive systems at scale that need to be reliable. So they've written these books. When I was at O'Reilly, the first book got written. That's the one that appears on the far right there, the Site Reliability Engineering book. They've since released the Reliability Workbook, which is a fantastic way to get hands-on. And they've also written one that's a little more focused on security. But for those of you who haven't read the book, the gist is this, that SRE is Google's implementation of DevOps. Thus, we're on DevOps.com. Reliability is very much a DevOps concept, or important to DevOps. So SRE is Google's implementation of DevOps culture with a particular focus for reliability, right? Site reliability engineering. But as part of this, they've taken those DevOps principles, they've filtered them through that lens of reliability, and they've come up with a number of principles. And I've kind of distilled them down to 4 here. And the first is ownership and collaboration. Within Google, service teams own their service. It's not owned by somebody else. The developers don't just write code, throw it over the wall, and let somebody else handle it. They own that. And the SREs actually work with them to do that. So SREs are embedded into teams. They're not a separate team. There's no separate DevOps team and a separate SRE team and a separate development team. They're all together. There's single cross-functional teams for each service. Right? This creates a sense of ownership, and it builds collaboration as those services interact with other services. The service teams will then interact with those other service teams. The other important principle, and a big thing that I think a lot of traditional organizations miss out on as they're building disaster recovery plans, is the idea that failure is normal. When we think of disaster recovery and we're only thinking of those catastrophic disasters, well, then they become rare events. How many times is an earthquake going to happen and take out a data center, or a hurricane going to take out a data center, or lightning strike my building and half of my servers go down, or my database goes down, right? If we think of things in that way, then failure becomes rare, and it becomes this thing that needs some sort of special planning. And again, that means it's not normal and it's not something we're comfortable with. Within SRE, failure is normal. There's an understanding that nothing is perfect. Everything operates in some sort of failure, from slight degradation and non-optimal performance all the way up to complete outages. If you understand this, then there's a need to start to balance reliability with innovation or feature work, right? Particularly with attention to the customer experience. How much do we value the things that the customer wants to see and be able to do versus the reliability of delivering the things that they expect? As we do this, then, if failure is normal, we have a new perspective of learning from it rather than just trying to resolve it. So learning from failure has led to things like blameless post-mortems, right? Blame doesn't lead to solutions. It only encourages people to hide flaws, hide those mistakes. and not actually solve problems. The other thing that it focuses on is there's no root cause. We think of contributing factors. Now, some people would like to say this, well, because everything's a complex system, which it is. But the other important part about this that I think is overlooked is that if you're not looking for a singular root cause, you're able to see all of the different things that contributed and fix those. And that way they don't contribute to other things, other outages or disasters in the future, right? If we solve for a singular root cause, we'll have a single solution that only works for that particular disaster or incident. The next principle is iteration and automation. Small changes reduce the amount of risk that we take, and they're easier to deploy. Automation further helps reduce that risk by ruling out things like manual error, and they improve that deployment speed. So it gets us doing things faster with less risk. And the final thing is to measure everything. This is one of the most important principles, I think, because if we're measuring everything, both our systems and our processes, it helps us have that knowledge of how to improve things. There's a great quote that a lot of people reference around this from H. James Harrington, a notable entrepreneur, who said that measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. So we need to measure these things. So all of these principles kind of come together, and they've been put into what's been called the SRE Pyramid. The pyramid essentially allows us to see what sort of skills and what sort of things we need to master or topics we need to master in the order of their importance, right? So if we imagine we're building a pyramid, the most important, that foundation, is that last principle of measurement. It becomes the foundation of everything that we do. So we have monitoring and observability as the most important thing we need to do, that foundation. This is often expressed in setting service level objectives and service level indicators. Service level objectives are the level of service or performance that we're setting as a goal. And those service level indicators are the specific metrics that make up that goal. So for example, an SLI could be that I want web requests that return a 200 OK response code in under 500 milliseconds, right? So good performance, no errors. That's a great goal. And so an SLO for this sort of thing would be that I want 90% of all web requests over the past 2 weeks to return a 200 code in under 500 milliseconds. Pretty straightforward. We have a target goal that we're shooting for. And the SLI for that, then, the indicator that I'm looking at would be those web requests, and again, judging on 200 code and under 500 milliseconds. The other important thing here is that error budget. That's the difference between our SLO, that 90%, and 100% perfect. And what we understand here is that now we're given a margin of room that we can play within, but rather than waiting for a disaster, right, when things are completely done, we are now saying that if I spend my entire error budget, that 10%, and I go out of bands, I return too many error codes, or my performance is dropped off and I'm returning responses above 500 milliseconds, I now have a very clear threshold of when I need to focus on reliability before it becomes a disaster. So it gives us a good boundary there. The next step up in the pyramid is incident response, right? This is traditionally what it would also include your on-call rotation, the processes that you do for escalation, how you define incident severity and escalate that up the chain, or who you notify. Also, how you communicate throughout the incident, both internally and externally to your customers. There's a ton of stuff to go through in this. So I'm going to leave it to my friends at PagerDuty. Response.pagerduty.com is extremely useful. As you're starting to build your DRP plan, take a look at that. They've done a lot of work on this framework, the PagerDuty framework of response, and how to actually run incident command. Start to work that into your DRP processes. But also how to do that, work it into your DRP, but also work it into your general incident response. Because again, we don't want to wait for those disasters. The next level up in the SRE pyramid is the post-incident analysis. And again, this is where we want to focus on learning and not blaming. So the things to include in this, the things that you should focus on include what happened, how did you detect it? Again, going back to that foundational layer of monitoring, trying to detect things earlier so they don't become disasters. Then try to capture how you responded, why things happened. Again, not looking for singular root causes, but looking for everything that could have contributed. And then setting those action items. There's, again, a lot about how to do blameless postmortem, so I'm not going to dive super deep into this, but that generally covers why this matters. After those foundational levels or layers, the pyramid moves more into deployment, development, architecture, and design. And I'm not going to jump too deep into these either because they start to stray, I think, too far from our DRP topic. But that said, I will leave you this link again. Go and read those books. They're amazing books and they're available online for free. So sre.google.com/books will get you all three of those. But in short, what I want to hammer home here is that rather than focusing on your singular DRP and whether or not you're confident in that, start to build that culture of reliability, because running reliability through your entire process and addressing issues earlier has a far greater impact on your ability to recover from a disaster than your traditional DRP will. So that said, you might be saying, culture schmulter or SRE schmessery, Jason, this all sounds good, but does it actually work, right? You're telling me to move things forward and resolve those small issues. Does that prevent disasters? Does it help us in recovering from disasters, or are you just full of it? How do we actually test for this? So this is where I usually come into organizations, because in my role, I actually get to work with a lot of our customers who have come to this for this reason, because they've had major incidents and disasters, and they know that this cannot happen again. So this is where chaos engineering comes in. You obviously don't want to wait for a disaster to strike in order to find out that your plans work or that they don't work. But also you want to be able to test to understand, well, did any of that SRE stuff or any of that DevOps stuff work? Does my incident response work? So some of you may have heard of chaos engineering. You've heard of Chaos Monkey from Netflix because it was probably the earliest, most famous iteration or implementation of chaos engineering. And you're like, how does randomly shutting off a bunch of servers actually help me? And the answer is this: well, chaos engineering really isn't just randomly shutting down servers and wreaking havoc or playing cruel tricks on your colleagues. At Gremlin, we like to say that chaos engineering is thoughtful, planned experiments that are designed to reveal the weaknesses in our systems, both our technical systems, but also our human systems. Now, thoughtful and planned is very important, and revealing weaknesses is the ultimate end goal, but the word actually I want to focus in on is experiments. Hopefully you remember back to your grade school days when you first learned about science and you heard of this idea, the scientific method, right? Well, if you can remember back from those days, what is a scientific method? Well, the main steps are this, right? You start with a hypothesis, and that's essentially, for a lot of people, that's a question of, is my system reliable? But I think the better hypothesis that you should start with is, under a set of conditions or failure, doesn't have to be a failure, but under some sort of set of conditions, does my application respond or act the way that I think it should? Again, that's a subtle change, but the nice change about this, about focusing on does your application respond or act or work the way that you think it should, is that this again sets up that learning. Because To be honest, most of us don't have super reliable systems. If your data center goes out, that's why you have a recovery plan. It's not intended to survive that, but you want to ensure that it responds in the way that you do so that you can start to test things like your plan. So create a hypothesis, run an experiment, essentially create those conditions, analyze the data, share, and iterate is the last step, right? So we have this question, does my application or system work the way that I think it does? I will inject that failure or cause that environmental stress that I want to. I'll analyze that data to see if my application works or behaves the way that I expect. And oftentimes it won't. And so that's what comes out of the analysis. You share that information so that everybody else knows, so that you're not hiding that information, and so that other people can learn from it. And then you iterate, you fix that, you rerun the test, and you keep working on this just like you would with anything else, constantly iterating to improve things. So you also probably remember, I just said the SRE principles of iteration. A lot of times people are like, well, Chaos Monkey, they randomly just like shut down a bunch of servers, and the first incident of this was, I think, Jesse Robbins at Amazon randomly pulling power cables. Well, that's all fun and good. Start small. Don't start with taking down entire fleets or even entire servers, right? Start with the basics and then increase that blast radius. Ensure that you can survive a single pod failure before you do a server failure or a node failure. And then once you're confident with a single node, you can scale up to a cluster, and then to an availability zone, and then to a region, and then to a cloud provider. And yes, there are people that are doing chaos engineering to simulate entire cloud outages and multi-cloud failovers. But you have to build up to that, right? Don't start there. Start simply, become comfortable with it. Now, the other thing that people ask me about chaos engineering is, well, do I have to do it in production? Like, that's what we do, right? It's got to be in production. And yes, production's a great thing, but you would never deploy code or make changes to infrastructure directly in production without first having confirmed or developed it in a development environment, and then deployed it to a staging or a QA environment. And then when you're totally confident in it, then you deploy it to production. The same happens with chaos engineering. Start in development, deploy that into staging, then deploy that into production when you're comfortable. Now that goes for chaos engineering, but the same can be applied to your disaster response. If I cause an outage in my local development, it's really easy to take down a database when it's just sitting on my computer, my local dev environment with sample data, and I can see how my application responds. And I can test my response to what that would be, right? I can run through the documentation of, if a database falls over, what do I do? So I can work with my local code to flip that over to another replica of that data. Makes it simple. And then from there, I can roll that up to staging and I can try again. And then finally, I can roll that up to production and test that response plan for when that database falls over. But I've then built up that confidence in order to do that. Now, obviously, though, people do ask that question, do I really need to do it in production? And yes, you do, because ultimately, everything that you do is in production. You would never say that, oh, I deployed code to my QA environment, I'm totally done, let's cancel out that ticket, right? You need to deploy to production because that's where your users live, unless the fix obviously was just specific for that staging environment or QA environment. But generally, you always want to roll up to production. So without actually doing chaos engineering testing on production and using chaos engineering testing to validate your response, you have no idea what would really happen if failure hit your production environment. So you have to do it in production. Chaos engineering is sometimes thought of as failure injection, but it's not always failure, as I mentioned. Sometimes you just want to test that things work the way that you think they work. With tools like Gremlin and chaos engineering, you can do a lot of things. And as you work through the reliability pyramid, you can start to test your foundational layers, right? Rather than waiting for a disaster. So with Gremlin, you could do things like consume CPU, memory, IO, and disk, or you can inject latency into the network. It's an easy way to validate your monitoring tools. Are they working? Are you seeing the right things, the things that you think you're seeing? When I worked at Datadog, it was extremely common to talk to customers and they'd say, I had an outage, I had a major disaster, and my dashboards didn't show me it at all. We got no alerts, nothing. Everything looked like it was normal. It's because they realized that they weren't monitoring the right things, or the metric that they thought was getting generated from a system didn't actually mean the thing that they thought it meant. So as part of your disaster recovery or disaster response plan, have you actually validated your monitoring? Chaos engineering makes this really easy, right? Again, I can consume resources, I can take things down, I can see if they send alerts, I can see if all of my monitoring tools and alerting is in place. The next level up, as we graduate from just that observability layer, our incident response, our alert set. One of the primary things that we did in postmortems at Datadog, the biggest question that we asked was, did we get an alert for this incident, right? So we can validate that. And then we can also start to verify that the right people were getting alerts, that our escalation processes worked, right? By injecting failure with chaos engineering, we can start doing what's commonly known as game days or fire drills. We can simulate an incident and then, or an incident or a disaster, and then test our response to it. The nice thing with chaos engineering though is we can control this failure. If something goes horribly wrong and we realize that that plan that we've developed doesn't actually work, or it's out of date, or the documentation is completely wrong, you simply stop it and nothing bad has actually happened to your systems. They come right back up, everything's back in place, you can reevaluate and then run that again. And then the third important foundational layer is that post-mortem, right? Or that post-incident analysis. As you're developing your disaster response or recovery plans, oftentimes you test them or you try to simulate them, but you're really waiting around for the next disaster to find out if they actually work. If chaos engineering, if you're starting to do that failure injection, you can very easily replicate those disasters and validate whether your plans actually go as expected or if they deviate. And again, the pyramid's pretty deep, so I'm not going to get super heavy into it, but after those foundational layers, the pyramid does move into those design and development and architecture phases. So if you start rolling out chaos engineering, you want to start knowing, can you automate the reliability testing of your applications, right? Rather than waiting for disaster or waiting for those incidents, you can start testing them proactively. You can also start to validate some of your design and architecture decisions. Does your auto scaling work, right? It's very easy to do dynamic sizing now with clouds. You can start validating whether those configurations or those setups actually do work. And then as you start to move into that design process, testing your dependencies, because a lot of times those major disasters, those major outages are caused from cascading failures. So testing what happens when one of my services goes down, how does that affect others? It's really easy to do with black hole attacks that will cut off services from the network. And ultimately, you do want to focus on that end user experience. That's the main thing for those SLOs is what does my end user expect and setting that threshold. So can we maintain a good end user experience when a certain type of failure or a certain type of environment is recreated? So I've gone through a lot of that, but again, some of you might be wondering, yes, but does this actually work, right? You've now told me that rather than a disaster recovery plan that just deals with disaster, I should incorporate culture and be all about reliability, and I should move that forward. And now you're telling me I should do chaos engineering to test all of that. Sure, it's easy for you to say on a webinar, but does it actually work? Well, one of the fun things about my job is I'm actually part-time a customer success manager. I work with a number of customers that Gremlin has, and I help them do chaos engineering. So here's a few of my favorite stories from our customers who have done chaos engineering with Gremlin. And the first is backcountry. We just had Black Friday not too long ago. For those who are maybe joining us from abroad, Black Friday is the day that everyone does their shopping within the States. Backcountry is this really great online store. They sell outdoor equipment like mountain climbing equipment, camping equipment. And as part of this, they have a massive warehouse filled with all of their goods that they're selling. And when someone makes an order, they have these robots that essentially pick up all of the things in the order, put it into a box, and ship that out. So a lot of times when we think about disasters, we're thinking about complete outages. And outages are horrible. They cost our companies lots of money. But again, if we're thinking of disasters not just as those major outages, but as all these incidents, well, the incident that hit backcountry wasn't a complete outage. It was that they had an issue that caused all of those robots to pick the wrong items and misship orders. This isn't something that's easy to solve. If we have a database outage, yeah, we can just say, well, we've got backups, and what's our recovery time or point objective? Cool, that's well within our means. Let's just do that recovery. You've just shipped hundreds of thousands, if not millions of dollars of stock to the wrong people. How do you recover from that? That's a very difficult thing. And how do you ensure that it doesn't happen again? It's literally impossible for them to have a secondary staging warehouse with staging robots that are going to replicate everything. So facing that 72-hour SLO breach in 2017, they came to us, they worked on a fix, and we decided to help them out with chaos engineering. We replicated that same incident and validated that those robots worked the way that they were supposed to. 2018, Black Friday went off without a hitch. So no problems at all. The other story that I really love is from MailChimp. MailChimp, for those who don't know, is an email service. They send over 5 billion emails every day for users, and that's users that are in marketing, that are doing marketing emails, or random end users that are just sending out regular newsletters to friends and family, like Christmas newsletters. Part of their service is to be end user oriented, to be customer focused, and to make all these little services that make their users' lives a little better. A lot of these services, though, aren't critical. So they decided one of the things that they would do was to test one of these non-critical services. What happens if it goes down? Well, as mentioned, you need to focus on the small incidents before they become disasters. And they found this out. They decided to black hole one of these non-critical services. And when they did, it took down the entire site, the entire application, everything, 503 error pages. The amazing thing, though, is, again, chaos engineering, it's really easy just to turn off that switch. So basically, very few people ever saw that 503 error. They were able to test it, realize that this non-critical service was actually hypercritical. They were able to test that, fix it, retest it again, and verify that it was outside the critical path without actually having it become a disaster. So just to recap what we've talked about today, as you're thinking about disaster recovery, maybe don't, right? Think less about what's my plan for a specific disaster, and start to think about, how can I build a culture of reliability that spans everything from the most minor annoyances and minor incidents all the way up to disasters? Because if you resolve them earlier, you'll have far fewer disasters, and you'll have the ability to practice and get good at that response, rather than having to test and run an exercise once a year to verify your DRP. And then the second is verify it with chaos engineering. If you're starting to work on things, injecting failure on your own terms in a very controlled way allows you to validate that your systems are behaving the way that you think that they are, that your processes are handling those incidents in the way that you think they should, and allows you to get good at them. So with that, that's the end. I've left plenty of time for questions. Again, if you want stickers or more information about Gremlin, go ahead and hit up that link, gremlin.com/talk/devops-drp. And again, just to reiterate, ask your questions in the chat, but if you think of anything later, feel free to hit me up on Twitter or via email. My information is on the screen there.
All right, great. Well, yes, as Jason said, there is plenty of time for question and answer period. We've gotten a couple in so far, but please don't be shy. Go ahead and get your question in. Just use the GoToWebinar control panel submitted in the Q&A section. Let's go ahead and kick off question and answer, see what we've got here. The first one, is the Gremlin, I guess, technology stem from the Netflix Chaos Monkey team?
Yeah, so yes and no. Some of our engineers were from that original Netflix team, but most of them came actually from Amazon. So Colton Andrus, who's one of the founders of Gremlin, actually started at Amazon. He did spend some time at Netflix post Chaos Monkey. So he essentially built the second iteration of all of those chaos tools that they use. And then our other founder, Forney, who's our CEO, again from Amazon, worked at other places like Salesforce. There are a lot of companies around that time that were doing similar things, but they decided, you know, at the time, Netflix's tools were only for Netflix. Amazon's tools were only for Amazon. Everybody should be able to do this easily. How can we make this a bit more abstracted and a bit easier for everybody to use? And so that's why they started Gremlin.
Excellent. Nifty stuff. Okay, next question here. Can you explain how a server being stateful or stateless affects disaster recovery methods?
Yeah. So stateless, obviously super easy, right? That's the hello world. That's when everybody shows off Kubernetes and it's stateless. So you just kill a pod and it spawns or gets rescheduled somewhere else. I feel like that's the easiest, right? Stateless workloads are easy to shift around. Stateful workloads are much more difficult, and that will definitely affect your disaster recovery process. So a lot of that really comes down to how you replicate your data and ensuring that you're replicating to enough places that if you need to switch that workload, it's available there. Chaos engineering is a fantastic way to do that, right? If I shut down a service somewhere, part of that thing is not only should that service come back, but it should reconnect back to that data set that it was accessing before, or if it was shut down and it was mid-flight, if I'm running like a data pipeline, well, then obviously I want something else to handle that data processing that it was, and I don't want to just lose that. So yeah, there's a lot of considerations there. Specifics will actually just be very specific to your situation. So if you have specific questions about how to do that, feel free to email me. And I can dive into those specifics.
All right, great. Plenty of time, guys. So if you have a question, go ahead and get it on in. We've gotten some great ones in. Here's another one for you. Say there's a discrepancy between staging and production environments in terms of scale, for instance. Does Gremlin help to address cases like this?
Yeah, so Gremlin can be applied to everything from the smallest environment to the largest. And our pricing model actually doesn't really care. Our pricing model is based on the number of uniquely attacked instances. So, you know, you can install us in your staging environment to get started, and then you can roll us out to tens or hundreds of thousands of nodes, as some of our customers have. And it really doesn't make a difference. You can have our agent sitting there for as long as you want on as many machines as you want, and it won't cost you really anything unless, you know, it's really just that attack. As far as the differences in those attacks, yeah, staging is never going to be exactly like production. So you want to test in both places, right? Again, you want to get comfortable in that staging environment before you move up to production. But as you mentioned, production will be different. So hopefully things react the same. Oftentimes there will be minor differences. And so running chaos engineering in production is very, very important.
All right, great. So just to follow up to that, just to clarify, chaos engineering implies tests within production, but you're saying also in staging, right?
Yeah, you want to do it everywhere, in every environment, right? So just like you would be developing code, I want to do that locally. I want to do that in a staging or QA environment, and then I want to do it in production. You want to do that with chaos engineering too, right? So you start locally, see what happens when the service I'm developing or working on goes down. Does it restart cleanly? Great. Push that to staging, try it again, ensure that it works the way that I think it does, and then do it in production.
All right, excellent. Okay, next question here. This is a little long and drawn out. So if in a way I get it right, my DRP will always be lacking something because reality has better ideas than I do. So I should build resilience into the system, which sounds obvious, but it isn't. What architecture should I be looking at?
Oh, that's a great question, right? What does resilient architecture look like? Generally, resilient architecture is going to look like a lot of loosely coupled services, right? That's the whole reason that we're seeing the explosion in microservices and cloud native, is this idea that if I have a monolith and it goes down, everything goes down. If I have small services and one of them goes down, well, hopefully, like we saw with the example with MailChimp, hopefully that's out of my critical path. And so I can lose a bunch of small services and my main core user experience doesn't get affected. So when I say loosely coupled services, you're asking, well, how do I actually implement that? Really, a lot of it comes down to having robust messaging queues, right? As services start to talk to other services, you want these queues available so that they can send things out, they can handle it asynchronously. Some worker on the other end can pick up that job, do the thing that it needs to do, return the result, and then things kind of have that intermediary. But then if one of those services goes down, it's just a queue. So that information is still there. And hopefully another worker will be able to pick up that job and still keep processing it.
All right, great. Here's a really great one for you. What's the difference between reliability and resilience?
Oh, reliability and resilience. There's a lot of contention around these words. So the three words actually that I want to deal with are reliability, resilience, and the other that you should keep in your lexicon or your vocabulary is robustness. So reliability is essentially the track record of having delivered to the end user what you've said you're going to deliver, right? And so you build up this track record, and you always get that financial advice: past performance not indicative of future performance. But generally it's true, right? If I say that Charlene is a reliable person, I can count on her, it means that generally I'm going to go to her when I need something in the future, and she'll probably deliver because she is an amazing person. To get there, though,
Jason.
to get there, she needs two things, and that's resilience and robustness. Robustness is the ability to just withstand whatever comes at her, right? Without flinching. You can think of, robustness as like a castle, right? I can shoot a castle with bows and arrows and they just bounce off, nothing happens. It just is there and it keeps everyone safe. And the same with your application, right? So robustness would be like, I have an application and no matter how much traffic goes to it, it's able to handle it, no problem. Great web servers like Nginx and Apache are built to do this. Resilience is the ability to adapt and still maintain that delivery, right? And so if we think about this is things like, degraded performance, but still being, gracefully degraded performance, right? So if I were to experience some sort of hardship like a data center going down, well, maybe I lose a little bit of those nice to have features, or maybe things get a little slower, but I'm still able to deliver that performance. So in having both of these, you're able to withstand issues, and when there's issues that you can't withstand, you're able to adapt to them and still deliver. And all of that contributes to being reliable.
All right. Nice to know you think I'm reliable. Okay, next question here. What DR methods would you recommend for the specific use case of a universal binary repository going down?
Ooh, Yeah, so specifically, I mean, there's a lot to this, right? It really
Right.
depends on what the uses are for this repository and what your objectives are in meeting, like who's accessing it, what are they getting, what those response times should be. Obviously, you know, the main things as you're starting to think about this are replication, right? So can I adapt to something being down? Am I resilient to that? Or am I robust if I'm getting too much traffic on it? So those are the first things when you're thinking about reliability. Obviously for that response plan, then you start to get into those more traditional of how quickly can I get back up? What's my general target time to get back up and running? And if I get back up and running, you know, what's the state of it? Is it the current, you know, set of data, or am I losing anything? And how much if am I willing to lose if I do?
All right, great. So we are about 10 minutes to the top of the hour. We have about 5 minutes left for question and answer period. So I think we can squeeze in maybe 1 or 2 or 3 more. So if you have any last minute questions, go ahead and use your GoToWebinar control panel. It's not too late. Let's see, here's another one for you. Does chaos engineering impact production's real-time performance?
Yeah, that's a great question. I would say that it depends on what chaos engineering attack you're doing. So it does happen in production. So yes, it will impact performance if the attack is big enough, right? The idea here again is we want to start small. So if I'm saying that, for example, on production system, I want to increase CPU to see if my application can withstand is robust enough to still operate when it's being throttled, you know, when there's not enough CPU. Well, I'll start with 5% and then 10%. And then at some point, I'll probably hit a threshold where, yes, that performance starts to degrade. But now I know where that is, and I can now plan, you know, do my capacity planning around that. So yes, chaos engineering will affect your production performance, but you're controlling for that, you're watching for that, and that's the whole idea. Is you're trying to learn where that point is, and then you have the control to be able to turn that off when you notice that it's gone a little too far or it's actually harming your customers.
All right, great. Okay, let's see. What factors go into determining how much downtime is acceptable?
Yeah, what factors determine how much downtime is acceptable? That is up to you and your business team and your customers, right? Oftentimes for a company, you might have an SLA that's actually a written agreement that guarantees that you provide a certain level of performance, or you owe the customer money or things like that. So that would obviously come into play. Usually we set our SLOs or our objectives to be a little more stringent than that, so we don't hit those or breach that agreement. But really, if you don't have that agreement as a guideline, it comes down to what do your customers expect, right? And you can start to run studies around this too. A lot of companies have run using feature flags or A/B testing. They'll try 2 different things out and see how a customer responds. Are we seeing a significant drop in, for example, online checkouts or certain user actions when something happens? And that'll allow you to gauge where that threshold should be.
Okay, we have a question that just came in. I think I'm going to make it our last question for the question and answer period because it looks like it might be a little convoluted here. Okay, here's a question related to DRP, but not quite SRE, or it can be considered part of. Global load balancing active across clouds regions would effectively kill the concept of DRP. Would you agree? The apps just never die.
Yeah, that's a great question, actually, and I love it. And that's one reason why I think that focusing on reliability across the full spectrum is important. I would agree that we now live in a world that if you are in the cloud and you build your application right and it's distributed globally and you've got things like CDNs and multi-region failovers or multi-cloud failovers, DRP kind of becomes a thing of the past because you've replicated that data everywhere. The only potential disasters that you can have are for those things like someone fat fingers a command, or there's some sort of bug and it actually actively destroys all your data and that replicates out to everything. So generally, yes, if you've constructed things well, you've now built up a system that can perhaps never really go down. So now you just need to deal with these small issues or these regional issues when it comes to reliability.
All right. All right. Well, we're 5 minutes to the top of the hour, so I'm going to close out the question and answer period. I think we may have not gotten to one question, but actually two. And actually, I do want to ask you this one question because I forgot to ask you at the beginning. And it's quite possibly the most important question of this webinar. Chocolate from scratch, cocoa butter and powder?
No, actually, I do buy raw cacao beans. One of the best suppliers or importers for the US is a place called Meridian Cacao. They're actually here in Portland, Oregon, where I live. So they import cacao beans from farmers. They do direct trade with farmers around the world and bring in cacao beans. So I roast them in my oven. I've got a machine that does the grinding on them, and then I turn that into chocolate.
Amazing. All right. Great. Well, thank you to everybody who did submit questions. If we did not get to your question during the question and answer period, please know that Jason and the folks at Gremlin are getting a copy of all of the questions that came in. So I'm sure he or somebody from the organization will be more than happy to follow up with you offline to get your question answered. Also, a quick reminder to the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, I did say at the top of the hour we'd be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and get to that. Our first winner today is David W. Congratulations, David. Second winner today, Carl with a K, M. Congratulations, Carl. Third winner today is Kathy with a K, D. Congratulations, Kathy. And our final winner today is Scott S. Congratulations, Scott. We'll be following up with all 4 of you offline by email to get your Amazon gift card over to you. So please check your inbox. If you don't see it in your inbox, please check your spam folder. Jason, what a great presentation. Thank you so much for your time, for your expertise. Lots of great stuff offered today. I really do appreciate it. And then judging from the number of questions we got in and the types of questions, I know the audience got a lot out of it too. So thank you again, really appreciate it.
Thanks for having me.
All right. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.